Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another GameMaker tutorial. I'm excited today because, I'm always excited, but I'm excited today because we're going to be doing another online tutorial, and this one's actually going to be a game. It's going to be a turn-based online game. You might get really excited when you hear that, but it's just going to be tic-tac-toe. But the base mechanics would work for any turn-based online game. So let me show you what we're going to be building first. Let me go to my desktop, and this is an example of what we're going to be building. So maybe if I can get it to run. Okay, there it is. Okay, they both came up. So I actually ran two games, as you can see. And you can see on this left one right here, you can see we're the X mark and it's my turn. On the right one, you can see that we're the O mark and it's the other person's turn, which just basically means it's the X person's turn. So let's go to this side. Well, let's go to this one first and try and click, and you can see that nothing happens because it's not our turn. So let's come over to this side and we can place an X. So let's place an X right there. Now you can see that it placed an X on our screen and it also placed an X on the other one. And it switched the turn now. So it's this person's turn. So I'm going to place one right there. Okay. Then we'll go back over here where we can place one here. And I'm going to do an X here. Okay. Now it's this person's turn. We better block them or they're going to get 3 in a row. So we'll click here. And then this person right here is obviously going to win because they can go here, boom, and then it's this person's turn, and there's no way to block both this one and this one at the same time. So they can just pick one, block it, and then we come back over to this, and X wins. Now I didn't actually do a win check in this, but that wasn't the point of this example. So there you go. You can see we've got that setup, and that would work over a LAN network. You could use something like Hamachi or Evolve to actually make that work globally. So let's get started. First thing we're going to do is create a new sprite. And I'm just going to call this, let's see, go to sprites. We'll call this sprite mark. And edit the sprite, come in here. We're going to do this, I think it's, 64 by 64. And we'll want 2 of them. Let's come into the first one. This one's going to be a circle. So I'm just going to do a circle. I don't want that outside part. If you hold shift, it'll force it to be a circle, which is useful. And transform. Actually, it's image, outline, and then just do 2, I guess. Oh, and this is also going to look familiar because I did a previous tutorial about a tic-tac-toe game using a DS grid, and this is basically the exact same game, only it's online. So that's kind of cool. Okay, let's color those in. Now let's go to the next one and make our X. So if you hold shift, it'll keep these like that, I guess. Transform, outline, perfect, paint it white, boom, we're amazing. Okay, so we've got our O right here is image 0, index 0, and the X is index 1. We're going to use that to our advantage later. And you can leave the origin at 0, 0. You don't want to center it. Just leave it at 0, 0. Now, we're actually going to create a background. I'm just going to call this BG space. And it's going to be 64 by 64. And I'm just going to do it. I don't know, 1 pixel's fine, I guess. Like that. Perfect. Okay, now we're going to create 2 objects. One of them is going to be called object network, And the other one's going to be called object game. And we're going to create, well, might as well create the room as well. So create a room. We're going to make this room 192 by 224, which makes it just slightly taller than it is high. Go to your tiles. Tiles. Okay, go back to the background. Use as tile set. And then do 64 by 64. Excuse me. Then we can use this as, turn off the grid. And we can use this to come down and draw the tic-tac-toe grid. Now, I left this space up here for the text. So that's why I made the room slightly different size. And let's call this room game. That's good. Sweet. So we're doing good so far. Let's work on our network first. So come into the network object, add an event, add a create event. So part of the thing that's nice about this example is we're going to have this one project work as both the network and the client. Basically, if the client, basically inside of this project, if there isn't a network available, it will automatically create one. And this is kind of a rudimentary way to do this, but it's a good way to show you a little bit more about how networking works. So first thing we're going to do is initialize the network. I hate spelling initialize. I need a hotkey that just does it for me. Var type equals network. Now, if you haven't watched my other one, you should go watch it, because I'm not going to explain a lot of this stuff as much as in detail as I did in my other network tutorial. So I'll put a link to that in this video, but you're going to want to make sure you watch that one, because I go kind of more in depth explaining these things. So that's the network type we're going to create. Var IP equals, okay, let me show you how to get your IP if you don't know. You can just go to command prompt and type in ipconfig, and you'll see one here, IPv4 address, and that right there is the one we can use for the LAN game. So mine is 192.168.1.100. And this should be quoted, or else it won't know what the heck it is. Okay, once you get your IP address, then you're going to want to do a port, var port, and I'm just going to use port 8000. There are a lot of different port numbers, and you can see, if you want to, you can look up the reasons for using different ones and whatever, but port 8000 works, so I'm just going to use that. Now we need to create a socket, and a socket is just a connection. It's kind of like the code version of what connects the two computers. Network create socket. We're just going to do type. Then we're going to check for a connection. So connection equals network connect, and we're going to pass in our socket and the IP address and the port. Now if connection, well, let's do is, we're going to create a variable called is server equals false. We're going to create another variable. This one's going to be a global variable called turn. Global.turn equals other. So you can see the default is for us to not be a server and for it to be the other person's turn, because the server gets to go first, I guess. Now we're going to do a check. If connection is less than 0. So what this does is, in this attempt up here to connect, if it can't connect, it will return a value less than 0. I'm pretty sure it's -1, but I guess it just says less than 0. It doesn't actually say -1. So if this connection right here doesn't work, then connection will be equal to less than 0. Basically what that means is there's no server. So if we can't connect to a server, that means there isn't one. At least in this case. That wouldn't always be the case, but so what we're going to do is we're going to create one. Global.turn equals mine. So if we are the server, then we want it to be our turn. Max clients equals 1. If I could, max clients spelled with an X. Server equals network create server. Then we're going to do type port and max clients. Now we want to destroy the socket that we created earlier because we actually don't need it anymore. So we're going to do network destroy socket. And then we're also going to set is server to true, is server equals true, because we are a server, and client equal to no one, because we don't have a client connected to us yet. So if we're able to connect to a server, then it's just going to ignore all of this code right here, and none of that will happen. We'll just connect to the server and set is server to false, set the turn to the other person, and then that's it. Okay, that's the end of the create event. Let's create a game end event. So add event other game end, and this is just some cleanup code to make sure we don't have any memory leaks. If is server. So if we are the server, else if we're not the server. If we are the server, we need to destroy the server. Network destroy server. If we aren't the server, we need to destroy the socket. Network destroy socket. Because in our create event, if we are the server, then we destroy the socket right away because we don't need it. But if we aren't the server, then we're going to be hanging on to that socket and we'll need to destroy it now when the game ends. Now let's create, let's do our draw event real fast because that should be a quick one we can get out of the way. Add a draw event. And this is just going to draw some information about the server. So draw the game information. Draw text to 0 turn, and then do plus global dot turn. So that's going to draw the turn. Var player text equals, I'm just going to do an empty string there, and if is server, then player text equals player x mark. Else player text, oh, I used a different, else player text equals player o mark. Sweet, so that's done. Then we're going to do draw text to 16 player text. That's just going to tell the player whether they're the X mark or the O mark. Now we get to do the fun part, which is the networking event. And it's not too bad. So add an event, go to asynchronous events, go down to networking, and we're going to do the networking event. do networking stuff. Just for fun. Var type event. So we're going to get the event type equals async load. Now this variable async load is only available in the networking event, so it's kind of a magic one. Question mark type. So I'm using the accessor. This is actually a DS map, a map data structure. So I'm using the map accessor in order to grab data from that. This is the key that we're looking for, and it's going to return out the value because a map data structure is a key value pairs. So switch type event case network type connect break case network type. Oh, I forgot the W. I was like, why isn't that working? Network type disconnect. Break. And one more case. Case network type data. So what do we do if we get data? Break. Okay. Now let's put some code inside of these. Oh, and this should be, I wrote that in wrong. So if I'm going to actually put another enter after these. So if another return, if they're trying to connect, we need to check if we aren't the server, then we don't care about an attempt to connect because we're not even a server. So if not is server break. Okay, so if we're not the server, break out of this. We don't even need to worry about it. If we are the server and basically client equals no one, which it does at the start, then we want to set the client. Client equals async load question mark socket. Okay. Now let's go into our disconnect because that's all we need to do is just keep track of the client. If not is server break, same thing. If we're not the server, we don't care about the disconnect. But if we are the server, client equals no one. And then we've already got break. So basically, delete the client. If we're receiving data, this is the harder one. Var buffer equals async load question mark buffer var socket equals async load socket. Oh wait, we don't even need that. We don't need the socket here. It's ridiculous because we only have one client, so we don't have to keep track of the socket inside of here. So we can just do buffer seek buffer seek start and 0. This just sets the reading position of our buffer. So a buffer is just a data structure that's sent across the network, and it's just basically like a list of information, and we're setting it to the start of that list. That's what buffer seek does. So we're going to actually call a script here. Script handle packet buffer. We're just going to pass in the buffer. Now we haven't written this script yet, so oops, that's not what I meant to do. So let's create it. Come up here to scripts because this is actually the last thing that we need to do. So we're actually done with that. But let's just write this script. Script handle packet buffer, because we're passing in a buffer. Var buffer equals argument 0 argument I need to get better at using the home and end keys, because those are really nice. Let's do var message ID equals buffer read buffer u8. So the first thing we're going to do with our buffer is we're going to read data from the buffer, and that actually removes the data. The first piece of information that we have chosen to store in our buffer, and I'll show you where we actually store it in the buffer. That's when we're sending the data. This is where we're receiving it, so we're on the receiving end. The first bit of information we've chosen to store is the message ID. Now you can use this message ID to tell your to tell your game to do different things depending on what the message ID. This actually kind of tells the code what is going to be contained inside of the buffer. Now we're going to do switch message ID. So based on what the message ID is, we're going to do different things. Case, place, mark. So we're going to place a mark. And we're going to read from the buffer. We're going to set the mark. And then we're going to start my turn. Because if we received information, that means it's actually the other person moving and it's now our turn. And then after that we're going to break. Okay, but this right here is actually, I've just made this a macro. So come to your macros, go to default, and then we're just going to call this place mark. And I'm pretty sure I set it equal to 0. It's fine. Okay, this will highlight once it catches up. Let's do the first part. Var grid x equals buffer read buffer u8. Var grid y equals buffer read buffer u8. So the first argument in the buffer read is just what buffer to read from, and the second argument is what type the data is going to be. And we're just doing an unsigned, yeah, I'm pretty sure this is an unsigned integer, 8-bit integer. Let's double check. Buffer u8, unsigned 8-bit integer. Man, I'm good. Okay. So once we read both of those pieces of data from the buffer, then we have the information we need to be able to actually create the mark, because that's going to be the x and y, well, the grid x and the grid y position of the mark. So we're going to do object game dot grid, which is going to be a DS map inside of the grid. We're going to do the accessor for a map, grid x, grid y, and then we're going to do equals not is server. Now that's a really tricky line, but if you remember, Boolean values can also be represented as zeros or ones. So not is server, if we are the server, then is server is going to be true. But then we're going to not it, which is going to set it to false, which is going to set it to 0. So if we are the server, then it's going to do the 0th index of our sprite. So it'll place a 0 there basically. Now if we aren't the server, then we're going to get a double negative, which is going to put us at 1. And that's going to place an X there, which is our image index of 1. Because we're storing the image index inside of this grid, not the actual sprite or anything. We're just storing the image index that we want to be displayed there. Then let's set our turn. Global.turn equals mine. And we're done with that script. Now that should, if we close out of it, come back into it, that should be script handle. Oh, it's because I didn't name it. Script handle packet. And I also forgot an E here. Oh. And for some reason I've got an error here. So case, place mark. Where am I missing something? Oh, no, that all looks good. What am I missing, guys? Do you see it? Script, unknown function, script. Oh, that's on the other page. Okay. I thought it was on this page. That was really confusing. It looked like there was an error inside of here. Whatever. Okay, yeah, you can see that that works now that we renamed the script, and it should show up correctly. Wow, that was really confusing for a second. Good job. We are now done with the network object. Let's go do the game object. So go into the game object's create event. We'll add a create event and drag over a code. And we're going to do create the DS grid and initialize the game object. Mostly we're just creating the grid. Grid equals DS grid create 3 and DS. Let me double check my macros, because I know we created more macros. Okay, come back to, go to the macros. Oh, let's see, I did it in default. And I've got place mark as 0, that's good. We're gonna do another one called blank mark, and that's gonna be set to -1. We're gonna be doing one called O mark. That's gonna be set to 0. Then we're gonna do X mark. That's gonna be set to 1. Then we're gonna do cell size. That's gonna be set to 64. Just in case you were to change the grid size in your game, this is gonna make it easier later to change that. So, okay, now we need to DS grid set region. We're gonna do grid, and then we're going to do 0, 0, which is the top left corner, to 2, which is the bottom right corner of our grid, and then we're going to set blank mark. So that's going to set blank marks, or basically, I think it's -1s, in every single cell of our grid, because this is the entire region right here. And that's all we need to do inside the create event. Let's do our global left pressed event. This is going to be one of the larger events. So go to mouse, global mouse, left pressed, drag over a piece of code, and we're going to do if global dot turn equals mine. Basically, we don't want to do any of this stuff unless it's our turn. Now the first thing we're going to do is grab the mouse position and convert it to a grid position. Why is that? Because the mouse's position is going to be in pixels, but we only really need to know where in the grid we need to place it. So var grid x equals mouse x div cell size. Now that's going to turn the mouse's X position into a grid value. Because the cell size is 64, div divides by that, but it returns the value with no remainder. So it's really good for basically snapping stuff to a grid. Var grid y equals mouse y div. Well, let's see, this one's a little different. We need to do parentheses mouse y minus 32. Why do we have to do minus 32? Well, it's because if you remember in our room, let me show you. In our room, the game actually starts 32 pixels above the top of the room. So we have to account for those pixels. So mouse y minus 32 div cell size again, and that gets us the grid y. So now we want to make sure this square, well, the cell isn't already taken, right? If grid x grid y, so we're accessing the grid location. If it doesn't equal -1, exit. So we're just going to exit out of this code. -1, actually we should do blank mark here. Blank mark, because that's what it is, right? If it doesn't equal a blank mark, then we want to exit, because that means it's already taken, it's not blank. So let's do send, let's see, set the mark, and you can copy this right here, and that equals object network dot is server. This is the same thing. If we are the server, this value is going to be equal to 1, which is going to set an X. If we aren't the server, this value is going to be equal to 0, which is going to set a 0 or an O. So send the action over the internets. Interweb nets. I had a friend that liked to mess around with internet, the word, but a more realistic description is the network. So var buffer equals buffer. He's still my friend. 1024 buffer fixed, and we'll do an alignment of 1. So what are we doing here? We're creating a buffer object that we can use to send the information over the network. It's going to have a size of 1 kilobyte basically, and it's going to be a fixed size, so it won't change size. We're going to do buffer seek buffer seek start, then we're going to do 0. So we're setting the position of the buffer to the very beginning, so we can write from the beginning. Buffer write buffer U8, that's the data type, and place mark. Now if you remember, the very first thing that we read from the buffer is the ID. So what's the very first thing we're writing to the buffer? Well, this is going to be the message ID. Place mark is the message ID that we wrote to that we read from the buffer before, and it was a unsigned 8-bit integer. So we're going to do now, what were the other two things we read from the buffer? Well, we read the grid X position and the grid Y position, so let's write those in. Buffer write buffer. Now you can basically write whatever you want to the buffer and read whatever you want from the buffer. You just want to make sure that they're coordinated. So whatever you write to the buffer in whatever order, you need to make sure you read from it in the same order on the other side. So grid X. I always do grid X. Buffer write buffer U8. And there are other sizes here you can see as well. Grid Y, but the U8 works great for what we're doing. Oh, it's because I got the... Man, I just can't put R's in the right places, can I? Okay. If object network dot is server. So if we are the server, then we need to send it to the client. Else, we need to send it to the server. So if we are the server, do network send packet, and then object network dot client buffer tell buffer. And then, so if we are the server, then we need to send it to the client, right? And you can copy this whole thing actually right here. If we aren't the server, then we want to set it to the server. So instead of client, do socket. If we are the server, we sent it to the client. If we are the client, then we need to send it to the socket, because the socket is basically our connection to the server. Okay. Buffer, delete. Once we've sent the buffer, we can delete it so that we don't store it. And then we can do global.turn equals other on our end. Awesome. Now, let's see, we need to draw the actual grid. And this is actually pretty easy. Draw event, draw the grid for var I equals 0. We're going to loop through the grid. I is less than ds grid width grid ds backspace and look at me already using and. I'm going to be so good at that. I++. Then we're going to loop again for, because that loops through the columns. We need to loop through the rows now, right? Width, if we're checking the width of it, then we're going to be looping through the columns. But the one on the inside, the loop on the inside, is the one that loops through the columns actually. So this should actually be height, because the outside is the rows. We loop through each column and then we go down a row. So var j equals 0. J is less than ds grid width. The reason it didn't matter when I had it the other way is because they're the same height, right? Or they're the same, the width and the height. So if grid I j equals blank mark, continue. Basically, if it's a blank mark there, we don't actually need to draw anything. So just continue through on to the next iteration. Var sub image equals grid ij var, let's see, draw sprite mark sub image I times cell size. Wait, yeah, this is the X position, which is going to be the, no, that should be J times cell size, I times, like I said, it doesn't technically matter, I don't think. Oh, we need to do, this one's got to be different. It's got to be, because of the 32 again, that we've got to add on to it. Plus 32. Okay, hopefully that works, because I actually changed my original code. So, file. In order to test it for real, we need to create an application. So create application. We're going to call this Tic-tac-toe vid. And I'm going to switch it to a single runtime executable. Save. And we should get a little console pop up here while it makes the game. Let's minimize it and let's run tic-tac-toe vid. Oh, well, duh. Maybe you guys won't be as silly as me, and you guys will remember to put the network object and the game object in the room. Okay. Now I've got to create an application again. Go to single runtime executable, and we're going to do tic-tac-toe vid. Yes, I do want to replace it. Okay, should be, let's see. Should be created now, tic-tac-toe vid. Hopefully we don't get an error. I'm going to allow access. Okay, well, that looks good so far. Got turn mine, player X mark, turn other, player O mark, so that looks good. Let's try actually creating stuff. Create an X there. The turn, okay, it created it over here. The turn switched to the other. Let's come over here, create an O right here. Ah, see. Yeah, I knew I was going to mess something up when I was changing it. Oh, maybe I should just do it how I originally had it. Let's come back into my code and look at it real quick. Think it through. It's probably because I did this in the wrong order. This should be J and I. J and I. Just like I did down here. Let's try one more time. If that doesn't work, let's see. Create application, tic-tac-toe vid. Make sure to switch it to single runtime executable. I hate it when it does it as an installer. I hate that that's the default. It's like I want to actually create an installer for every single build that I do. That's ridiculous. I just want a quick executable where I can run 2 versions of the game at once. So here comes our first one. Should come up. There it is. Pull up our second one. There we go. Place an X here. That worked that time. Let's create an O here. Come back over here and create. Let's create an X here. We'll come back over here. Create an O there. Boom, messed up both your things. Then come over here, create an X. This is gonna be a cat. And I'll come back over here and create an O. And they're like, no, we can't let you win. So they create an X here, and then an O here, and then an X here. And it's an X wins because I was just clicking and not paying attention. But yeah, seems to work quite well, and looks like there's no errors that I can see in any way. So there you go. You built your first LAN game, a turn-based one that works pretty well. Congratulations. It's a lot of fun to build multiplayer games. I had a lot of fun building this one, even though it was just tic-tac-toe. And I've got a whole bunch of ideas for other games that I could use that were turn-based, that use a similar system like this. And the reason turn-based games are great for online is because you don't have to worry about lag and syncing up stuff, and it's just way easier. You can send information in simple tiny little packets like this. You could actually just send a command that says run this command, and then when it gets to the other side it says, oh, okay, I'll run that command. And that's a really smart way to do it. So anyways, hope you guys learned something. If you enjoyed this video, be sure and like it, favorite it, add it to a playlist, subscribe. Always subscribe. Share the video on Facebook and Twitter. That always helps me a lot. Really appreciate you guys. And I will be talking with you guys later.